Good day, students. Today our topic will be direction by angular bearing. It is one of those techniques that we use to find direction. The other one is the compass direction. So the difference is, instead of using north, south, east, and west and other points on the compass, we are going to give our direction in angles. For example, 90 degrees, 360 degrees, 240 degrees, and so on. So let's get right into it. There are several things that we need to take into mind whenever we are doing angular bearings. First thing, we need to understand that angular bearing is used to give the exact location of a place. It's more exact than the compass direction, right? Secondly, it is expressed in degrees. Now we normally read our bearings in a clockwise direction from 0 degrees all the way around to 360 degrees. So it's a full circle in which we are carrying out this exercise. As I said a while ago, the bearing is read in a clockwise direction, and we normally use a protractor. The typical protractor that is in your geometry set is the semicircular one, but you also have the full circular protractor, which makes everything a little more easier for you. But regardless, we're still going to be able to carry out the exercise. Next, all places that are generally east are between the angles 0 and 180 degrees, and I will explain that to you as we go on in the practice. And all places west, generally west, anywhere west of the point of observation is between 180 degrees and 360 degrees. This instrument is what we call the protractor. I'm sure you know this by now. If not, this is what we call the protractor. And this is what you will tend to see in the regular geometry set. However, as I said a while ago, you have the one that is actually 360 degrees, the full 360 degrees. When I was back in teachers college, that's the one that I normally used. I never actually used this one, but I still know the technique in employing this one. Whenever we are using the protractor, we normally read the numbers on the outside. All right, let me just make that a little easier for you. Let me get my laser pointer here. All these numbers out here, 0 all the way down to 10, 40, 50, 60, 70, 80, all the way to 180 degrees, these numbers on the outside here, these are the ones that we're reading. Alright, so we only read the numbers on the outer part of the protractor. So whenever we're taking our bearing, we read our bearing or our degrees going in a clockwise direction, but only the numbers on the outer part, not the numbers inside here. Please do not read these numbers on the inside. Alright, we only read the numbers on the outside. These are the ones that we use. And just the same way you see this protractor being positioned, that is how we're going to position it on the map. I know that in other subjects, like in mathematics, for example, it is placed horizontally. But in geography, when we're taking our bearings, we place the protractor vertically. So how do we find our bearing? First thing, we must determine our from point or our point of observation. In other words, then, normally in bearing, we are normally given 2 points. We're given a point A and a point B. Now, point A and point B are relative. They can be a post office, a church, a school, a fire station, a police station, they can be a power station. They can be basically a trigonometrical station. They can be basically anything. All right. So usually the place that comes after the word from within a statement or an instruction or a question that is going to require you to find a bearing is what we call the from point or the point of observation. It's where you're going to actually stay to determine your bearing or your angular bearing, or to observe your bearing. Say for example, to draw a straight vertical line, you're going to draw a straight vertical line through the from point. All right, and this is the stated question. State the bearing of point B from point A. Now let me go again. State the bearing of point B from point A. Now if you listen carefully, all right, you have 2 points, B, point A. Now point A comes after the word from. So obviously point A is going to be our point of observation, or simply our from point. It is where we're going to stay to find the bearing of point B, because we want to know the bearing of point B. That is the place we want to know the bearing of. So right away we determine where we want to know the bearing of and where we're going to stay to take the bearing from. All right, so therefore point B is the place that we want to know the bearing of, since it says that we must state the bearing of point B. But we are going to stay at point A to take our bearing of point B. So point A would be our point of observation or our from point, since point A comes after the word from in the statement that was just given a while ago, the instruction. Okay, so now here is our point A. Then we have our point B. Now remember class, we said that we want to know the bearing of point B from point A. So therefore, point A is our from point or our point of observation. So it means therefore that the very first thing we're going to do at the from point or our point of observation, which in this case is point A, we're going to draw a vertical line right through it. A straight vertical line. Notice I said straight vertical line, right? The reason for drawing this line is that it is supposed to guide us in placing the protractor properly on the paper. All right? So it is important that you draw it as straight as possible. If you lean it, it's going to give you, when you place your protractor on that line, it's going to give you an incorrect reading or something slightly off, right? Now, if you draw it too small, that is also going to pose a little problem for you. So it's important to draw it long enough so that it can easily be manipulated on your paper. All right. So once again, we draw our vertical line right through our point A, which is our point of observation. Then we are going to now draw a line from the center of point A directly to the center of point B. Now this line is the line that is going to pass through the protractor to tell us exactly what the bearing of point B is, or the angular bearing of point B is from point A. Okay, so we're now going to place our protractor right here. As you can see, the line is long enough. It's almost as long as a protractor, so I'm able to manipulate that line. I'm able to use it to my full advantage and line up my protractor properly on it. Now, the way in which I place my protractor, that black line that runs from the 0 all the way down to the next 0, this black line right here, make sure you position that black line exactly on the line, that vertical line that you drew. All right, so That is how you must place your protractor on that line. Now, as you can see, the green line passes right through a certain point here. All right. So first thing is first, we're reading in a clockwise direction. If you follow the direction of the yellow ball, and it stops right on the line. Now this line, as I says, tells us exactly the bearing of point B from point A. And if you look carefully, the bearing of point B from point A is approximately 115 degrees. So the bearing is 115 degrees. Here we have our 115 degrees. This is 110. This is 100. So we have 100 right here. 105, 110, 115, and we have 120 right here. So the bearing of point B from point A is 115 degrees. Class, it's important that when you're stating or writing down your bearing, that you make sure to write the degree symbol. If you fail to do that, even if it is accurate, you are going to lose marks or may not get any marks any at all. So make sure that you include the degree symbol in your answer. So it is 115 degrees, which is the bearing of point B. All right. Let's move on. Let's carry this to another map. So here we have our map, and we're going to determine the bearing of the electricity station from the tourist office. All right, so we want to know the bearing of the electricity station, which is right here, from our tourist office, which is right here. Already, as you can see, I have drawn my marker right through it, my line, my vertical line. Now I'm going to connect them by a straight line like that. And next thing, I'm going to put my protractor on my vertical line right here. As you can see, it's properly positioned right there. Now, when we look at our marker, we can see that it has passed right through 100, and this looks more like 134 degrees, not exactly 135, but it's at 134 degrees. So the bearing of the the bearing of the electricity station from the tourist office is 134 degrees. That is the bearing of the electricity station from the tourist office, which is 134 degrees. Let's try another one. So just for emphasis to show you where it is positioned. All right, let's try another one. So now we want to know the bearing of farm A from farm B, and there we draw our line again through our from point, which is farm B. Then we connect them with a straight line, and now we're going to put our protractor right here. Now, in looking at that, we can see that it is 31 degrees. So the bearing of farm A from farm B is 31 degrees. Again, the bearing of farm A from farm B is 31 degrees. So here is the 31 degrees shown here. So we have 0, 10, 20, 30, and 31. So the line passed right through the 31 degrees. So it is 31 degrees, the bearing of farm A from farm B. So the bearing of farm A from farm B is 31 degrees. So Let us now look at another scenario. I'm gonna double it up a little. Now, we want to know the bearing of point B from point C. Okay, now remember we said that place is generally west of the point of observation, or the from point is between 180 and 360 degrees. Okay, that is what we're going to be doing now. All right, a while ago we just did the easier of the two, where the point that is east of the places are usually generally east of the from point. All right, but what if you have your semicircular protractor and you're asked to find the bearing of a place that is anywhere towards the west of the from point or the point of observation? Then we'll have to dig a little deeper to understand how we're going to work that out and why. Alright, so here's the first thing we're going to do. So since C is our from point, or our point of observation, remember we are to draw a straight vertical line through point C, just like that. Then we're going to connect point B and C by a straight line. Okay, now here's where the magic happens, and I want you to pay keen attention now, students. So my protractor is right there on the line, properly placed on the line, but this is something that we need to observe now. Now, since over here on this side of the line, this is a straight line. So what is the angle of a straight line? If you say 180 degrees, you are indeed correct. The angle of a straight line is 180 degrees. So we know that for a fact that over here is already 180 degrees. We have this one locked already. What we are interested in to know is the angle right here. This one from here to here. We need to know this little angle. Again, we're reading a clockwise direction, and we want to know the angle right here, this little angle. This is the angle in which we are interested in right here. This is the angle. So once we turn our protractor this way, we are now going to try to see which angle is right here. Now, based on what we have here, the angle right here is 70 degrees. It is 70 degrees. But that is not our bearing for point B. The 70 degrees is only the angle of right here. We need to know what is the total bearing. So the next thing we're going to do is to add 70 degrees to 180. And that should give us approximately 250 degrees. So, as we said, the line passes through the 70-degree angle right here on the protractor, the outer number. So it means, therefore, we're going to then add 70 degrees to 180, because remember, students, over here is already 180 degrees. We want to know the angle between our vertical line right here and the line that we drew connecting the two of them, this angle right here. And we found out that the angle is 70 degrees, so we just simply add 70 to 180 degrees to get the total bearing. So the bearing of point B from point C is 250 degrees. So we're going to state our answer, and by stating we mean to write our answer in a sentence. The bearing of point B from point C is 250 degrees, because what we did, we found out what angle the line passes through right here, which is 70 degrees, and we just simply add our 70 degrees to the 180 degrees over here. all right, which is already established. Once we did that, we're going to get our total bearing, which is 250 degrees. So let us then now connect our line to point A from point C, because now we want to know the bearing of point A from point C. Again, our interest is this entire angle right here, just this angle, because we know already over here, between here and here is 180 degrees. We want to know this little angle right here. Now when we look at our protractor, we can see that the line has passed right through 105 degrees. It has passed through 105 degrees. So what are we supposed to do with that 105 degrees now, class? Okay, if you say that you're going to add it to 180 degrees, you are indeed correct. We must now add it to 180 degrees in order to get our total bearing. So we're going to say 105 plus 180 degrees should give us approximately 285 degrees. And that is the bearing of point A from point C. Again, all we have to do is to find out which number or how many degrees on the protractor does this line passes, the one that connects point C to point A. All right. And as we look carefully, we see that it has passed right through 105 degrees. All right. Again, the outer numbers. And since that's passed through 105 degrees, we are going to add 105 to 180, which should give us 285 degrees. And that is our bearing right there for point A. So let us state our answer. Let us give our answer in a sentence now. The bearing of point A from point C is 285 degrees. Let us go back onto our map. What do we want to find the bearing of now? So I want to see what is the bearing of the bus station from farm A being our point of observation or our from point. So we already draw our line through our point of observation, which is farm A, and then we have connected the two of them by a straight line. So we connected farm A to the bus station by a straight line. Then we're going to put our protractor right here. Okay, now looking carefully, I can see that our line has passed right through 61 degrees. So 61 plus 181. How much is that? My math is a little rusty, but let me see now. 61 plus 81 plus 181 would give us 1 right there. Then the 8 would give us 14. So it should be 241. 241 degrees is the bearing of the bus station from farm A. So the bearing of the bus station from farm A is 241 degrees. Again, the bearing of the bus station from farm A is 241 degrees. All right, good. I think we're making progress. Let us try another one. So for emphasis to show you where it is placed. Alright, so I want to know now the bearing of the hotel resort from the bus station. So now our bus station is our point of observation, is our from point. And we want to know the bearing of the, and we want to know the bearing of the hotel resort. from the bus station. So we're now going to place our protractor on that line right there. And let's take a good look to see where that is. And based on what I'm seeing here, that is 119 degrees. The line has passed through 119 degrees. So let's see now, 119 plus 180 should give us, let's see now, we have the 9 right there, then we have another 9. Okay, then it should be 299 degrees. I hope my math is correct. Let me see, 180 plus 119 degrees. So it should be 180 over 119. So it should be 9, then 9 again. Yes. So we are right. 299 degrees. Just 1 degree shy of the 300 degree mark, but it is still our bearing. So the bearing of the hotel resort from the bus station is approximately 299 degrees. Again, students, the bearing of the hotel resort from the bus station is approximately 299 degrees. Remember, once we find where the angle is here, where the line passed through, we just simply add it to 180 degrees. All right, because we already know that it's already 180 degrees over here. We just want to know this angle right here, which is 119 degrees, and we add that to 180 to get the full bearing of the hotel resort. Remember, students, once the places are generally west, anywhere west of the from point, could be here, 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 down here. As long as it's generally west of the from point, we have to locate our angle and then add that angle to 180 degrees. If it is to the east, we don't have to add anything. So if it's anywhere over here, let's just say our bus station is right here, and we're looking for the bearing of either village A, farm B, village B, or farm B, or even the factory. All we have to do is just put our protractor here, and we just locate our degree, and that's it. We don't have to add nothing. But since the places are generally located to the west right here, we have to find the angle and then add it to 180, because remember, we're going in a clockwise direction, so we have to follow in this direction. All right, so like how we find it to be 119 degrees here, right, we just simply add that to 180 degrees and we get our full bearing of 299 degrees. Again, for emphasis, just to show you how it is placed on the line. Okay. So now we're going to take it a step higher. We're now going to be working with an actual map. And this is the map of Lucy in the parish of Hanover, right? Now, here we have our activity that we're going to do. So we want to find out what is the bearing of the market from the school at Fat Hog Quarters near New Providence right here, right here. So here's our market in Lucy. We want to find the bearing of this market from this school right here. All right. So we're now going to draw our line and place our protractor right through that, right along that line, right where the school is. So we're right on the school. We have also drawn our line there to guide our protractor, and then now we're going to connect the two of them by a straight line. Again, we're going to make this straight line using our ruler and pencil. All right, so when we look at that now, I see here it is 71 degrees. So the So the bearing of the market, so the bearing of the market from the school at Fat Hog Quarters is 71 degrees. Again, students, the bearing of the market from the school at Fat Hog Quarters is 71 degrees. All right, let us try another one. Here's a little activity we're going to try. We're going to find out what is the bearing of the factory between Riley and Johnsontown from the factory near Elgin. We're going to also find the bearing of the road junction at Esher from the market in Lucy. Also, we're going to find the bearing of the church between Providence and Mango Valley or Mango Hall, all right, from the postal agency, all right. And then finally, we're going to look for the bearing of the health center in Lucy from the bridge at Q. Okay, so let's look at the first one. We want to know the bearing of the factory between Riley and Johnsontown from that of the factory at Elgin Town or near Elgin Town. So here we have our factory near Elgin Town. That's our from point, our point of observation. We're going to draw our straight line through that. Then we're going to connect them with a straight line like that. And now we're going to put our protractor right there. Now looking at the protractor, we can see it's between 40 and 50, our angle right here. So it must be 45, right? So therefore, we're going to add 45 to 180. Remember, it is generally west. It is towards the western side of the factory here. So we're going to have to add to 180. So 45 plus 180 should give us approximately 225, yes, 225. So 180 plus 45 should give us 225 degrees. So the bearing of the factory right here between Johnsontown and Riley from that of the factory near Elgin is actually 225 degrees. So the bearing of this factory right here between Riley and Johnsontown is 225 degrees. That is the bearing of our factory right there. Because again, class, we are going to add to 180. We're going to add our 45 degrees right here to 180. All right, since over here is already 180 degrees. So we're just going to add it to 180 to get our full bearing. Now now we're going to try to find the bearing of the road junction right here at Esher from our market right here in Lucy. So already we have drawn our line right through the market. We're going to connect them with a straight line like this. So right here is the road junction. Now we connect our straight line to the road junction. Then we're going to now put our protractor right there, making sure that the center of our protractor is also right on the market itself, which is the little black box that represents the market building. Now looking at that, we have here 103 degrees. So we're going to add 103 degrees to 180, which should give us approximately 183 degrees. Nope, 283 degrees. Sorry about that. So the bearing of the road junction, right, which is right here, from the market at Lucy is 283 degrees, because when we come here, we see that it is 103 degrees. The line passes right through 103 degrees on the protractor, right, which are the outer numbers here. So we're going to add that 103 degrees to 180, and it should give us approximately 283 degrees. So the bearing of the road junction from the market is approximately 283 degrees. All right, next one we're going to try to find out is the church. Here's a postal agency down here, and we want to know the bearing of the church right here. Here's our church. Here is our postal agency. So we have our line drawn right to the postal agency already. And here is our church right here. So we're now going to connect them by a straight line like that. We're going to put our protractor right there. And just like that, 20 degrees. So the bearing of the church from the postal agency is 20 degrees. Again, here's our postal agency right here. Here is our church right here. And we want to know the bearing of the church from the postal agency. It is 20 degrees. If you look carefully, our line passed right through the 20-degree mark. So it is 20 degrees exactly. Again, students, do not write your bearing without the degree sign. You will either lose marks or don't get any at all. So make sure that when you're writing down your degree, you make sure you put your degree there. You're writing a bearing, you put your degree sign there. Now, I want to make something clear. You don't have to be exactly on the money, because sometimes things happen and you don't get an exact reading. So let's just say, for example, the examiner has 20 degrees as the exact answer, right? But you get 19 degrees. If you get 19 degrees, you are still correct. If you get 21 degrees or even 22 degrees, you are still considered correct. All right? Anything a little too far off, you are going to be incorrect. So just to let you know that there is a margin of error, but it's always good to try and be as exact as possible. As long as your lines are straight, and you place your protractor properly, you should, for the most part, come up with the exact answer. But as I said, sometimes things happen and you are a little off, either a little less than the exact mark or a little more than the exact mark. If you go over by 1, you are still correct. If you are less or short by 1, you are also correct. Okay, good. One more. We want to know the the bearing of the health center from the bridge at Q. So here we draw our line through our bridge at Q already. Then we're going to connect them by a straight line like that. So there is the health center. As you notice, the line goes exactly to the health center building. And then now we're going to put our protractor right there, exactly where the bridge is. Now when we look at that, look at that. That looks like 128. Yes, 128 degrees, that's the angle. So let's add 128 degrees to 180. So 128 added to 180. So here's the angle right here. So 128 added to 180 should be approximately 308. Yes, 308 degrees. That is the bearing. So 128 plus 180 should give us approximately 308 degrees. All right, so it is 308 degrees. That is the bearing of the health center from the bridge at Q. Once again, 128 plus 180 should give us approximately 308 degrees. So 308 degrees is the bearing of our health center from the bridge at Q. Again, 308 degrees is the bearing of our health center from the bridge at Q. All right. So that is the end of our lesson on bearing, angular bearing. I hope it was informative and you learned something new and you fully understood what was presented. If not, feel free to review the video as much as possible. Thank you all. Enjoy yourselves. Have yourselves a great day.